Today we'll be talking about solving absolute value equations. We're looking at lesson 1-4 on page 27 of your textbook. The Common Core state standards are listed below. Please take a moment to pause and read the content standards, and the mathematical practices we'll be working with this lesson. Our new vocabulary: absolute value, empty set, constraint, and extraneous solution. We have a key concept from your textbook, and really it's discussing absolute value as how far the number within the absolute value signs are from zero. So the absolute value of a number is its distance from zero on a number line. Since distance is non-negative, the absolute value of a number is always non-negative. When evaluating expressions, absolute value bars act as a grouping symbol, so you perform any operations inside the absolute value bars first, just like you would parentheses. Example 1. So they're asking us to evaluate 8 4/10 minus the absolute value of the quantity 2n plus 5 if n is equal to negative 7.5. So this n equals negative 7.5 gives us a clue that we need to substitute a negative 7.5 in for n. We've got absolute value symbols here. So what we're going to do first is the work inside. We've got parentheses inside, so we're going to go 2 minus 7.5 gives us a negative 15 plus 5. We still have the grouping symbols. Negative 15 plus 5 gives us a negative 10. Now the absolute value of negative 10 is just how far it is from zero. So a negative 10 is 10 places from zero. However, we still have this negative sign out front that does not get changed by these absolute value signs. So we simplify to 8.4 minus 10. Our larger number is negative, so our answer will be negative. So the difference between 10 and 8.4 is 1.6. Now I'd like for you to work the guided practice on page 27, problems 1A and 1B. So please pause for a moment and take time to work those problems. Here are the answers to 1A. The answer to 1A is 1.5. The answer to 1B is 1. So if you didn't get these answers, please go back again, see where you might have made a mistake, and rework the problems. Now for a real-world example. This is also in your textbook. A standard adult tennis racket has a 100 square inch head plus or minus 20 square inches. Write and solve an absolute value equation to determine the least and greatest possible sizes for the head of an adult tennis racket. So first of all, we need to understand what the problem is asking us to do. We need to determine the greatest and the least possible sizes for the head of the tennis racket, given the middle size and the range in sizes. Our plan is when writing an absolute value equation, the middle or central value is always placed inside the absolute value symbols. The range is always placed on the other side of the equality symbol. So notice our central value is placed within the absolute value. The range is on the other side of the equality symbol. Now we're going to solve x minus c. The absolute value of x minus c is equal to r. We don't know what x is, but we're going to subtract from it 100 because a standard adult tennis racket is a 100 square inch head. And then it's plus or minus 20 square inches. So we're going to have it equal 20. Case 1, where a is equal to a positive b, x minus 100 equals 20. So now we're going to add 100 to both sides so we can solve for x. Then a minus negative b, so it could be minus or less 20. So we solve on this one, we'll have x is equal to 80. On the first case, x is equal to 120. Now let's check our solution. So is the absolute value of 120 minus 100 equal to 20? It is. So that is a good possible solution, 120. Is 80 minus 100, taking the absolute value of it, is it equal to 20? It is. So on a number line, you can see that both solutions are 20 units away from 100. So the solutions are 120 and 80. The greatest size is 120 square inches, and the least is 80 square inches. Now time to pause for a moment, work the guided practice on page 228, problems 2A and 2B. Here are the answers to the guided practice you just worked. 2A, the solutions are negative 21 and negative 3. And for 2B, the solutions are negative 13 and 3. If you did not get these answers, please go back and rework them to see where you might have made your mistake. A couple of tips. It may be helpful to read the first absolute value bar as the distance of, and the last absolute value bar as from 0 without regard to direction. So if you're reading the absolute value of 6x minus 2, you could read it as the distance of 6x minus 2 from 0 without regard to direction. Now, because the absolute value of a number is always positive or 0, an equation like the absolute value of x is equal to negative 4, that's never true because your answer is never negative. Thus, it has no solution. So the solution set for this type of equation is known as the empty set, which you can symbolize by just braces with nothing between, or the null sign. So let's look at example 3. We're going to solve the distance from 3x minus 2 from 0 without regard to direction plus 8 equals 1. So we've got the absolute value of 3x minus 2 plus 8 equals 1. We can't do anything inside the absolute value sign, so we're going to start by subtracting 8 from both sides. So we have 3x minus 2 is equal to negative 7. Well, that is never true. So the solution set is the null set or empty set. Now I'd like for you to work the guided practice on page 29, problems 3A and 3B. So pause the video while you work these problems. The answers to the guided practice. For 3A, it is the null set. For 3B, it is also the null or the empty set. If you did not get this answer, please go back and review your problems to see where you might have made an error. In mathematics, a constraint is a condition that a solution must satisfy. So equations can be viewed as constraints in a problem situation. The solutions of the equation must meet the constraints of the problem. So a constraint to an absolute value could be that it has to be a positive answer. It cannot equal a negative number. Even if the correct procedure for solving the equation is used, the answers may not be actual solutions to the original equation. Such a number is called an extraneous solution. So example 4, we're to solve the absolute value of x plus 10 is equal to 4x minus 8, and then to check our solution. So first of all, this could equal the positive 4x minus 8. Case 2, it could equal negative 4x minus 8. So we're going to solve for the positive first. So we have 4x is the larger of the x's. So let's subtract an x from both sides. That'll leave us 10 equals 3x minus 8. Then let's add 8 to both sides. So 3x is equal to 18. Then divide both sides by 3. So for the positive side, we're going to have x is equal to 6. Now what if we have a negative b? So we're going to distribute this negative sign across 4x minus 8 to get negative 4x plus 8. Now that we have a negative 4x, let's add 4x to both sides. Have 5x plus 10 equals 8. Now let's subtract 10 from both sides. So 5x is equal to negative 2. Then divide both sides by 5. So x is equal to negative 2/5. So there appears to be two solutions, a 6 and a negative 2/5. Now let's go back in and check our solutions to see if both of them work. So in place of x, we're going to put our 6. So we'll have 6 plus 10, the absolute value of 6 plus 10. Is it equal to 4 times 6 minus 8? Is the absolute value of 16 equal to 24 minus 8? Yes, it is. 16 is equal to 16. Now let's see if we substitute in a negative 2/5 for x. We end up with the absolute value of 9 3/5. And on this side, we end up with a negative 9 3/5. So this one does not check. So the solution negative 2/5 is an extraneous solution. So the only solution is 6. Now I'd like for you to pause, do guided practice on page 29, 4A, and 4B. Answers to the guided practice 4A is the solution set 3, and for 4B is the solution negative 1. Good job. Now you're ready for your assignment.